You're not slacking in physics. You study longer than most people. You do more problems. You put in the hours. And yet, your grades don't move. That doesn't feel fair, and it shouldn't. But there's a reason this happens. I'm the physics sensei, PhD in physics, black belt in karate, and 30 years teaching college students just like you. My job is simple to train you the right way so effort finally turns into results. Today, I'm going to show you why studying harder still doesn't work in physics and what actually does. If nothing changes, here's what happens. You keep adding hours, you keep pushing harder, you start doubting yourself. That cycle doesn't build skill, it builds burnout. And eventually, students don't fail physics, they just quit trying. So here's the truth: physics does not reward effort, it rewards effective training. Most students aren't failing because they don't work hard. They're failing because the effort is aimed to the wrong targets. So in this video, we're going to break down 5 reasons why effort alone doesn't translate into results in physics. The first instinct students have is simple. If I do more problems, I will get better. That sounds logical, and it's wrong. Here's what's actually happening. You're doing problems, but you're not fixing mistakes. You repeat the same thinking. You repeat the same step errors. You repeat the same guesses. And practice without correction doesn't build skill. It reinforces habits. Most students believe if I do enough problems, I will get better. That's not how learning works. If you practice the wrong move, you don't get stronger. You get consistent and being wrong. That is why homework feels productive. You finish pages, you check boxes, you feel busy. But busy is not the same as improving. Improvement only happens when you know what went wrong, why it went wrong, and what to change next time. On exams, repetition gets exposed. The problem looks different. The numbers change. The surface shifts. And suddenly, your practice doesn't transfer. Because what you trained was completion, not correction. Strong students practice differently. They slow down. They review mistakes immediately. They ask, what decision failed here? They don't rush to the next problem until the error is understood. That's how skill is built. Doing more problems feels productive. Fixing mistakes feels uncomfortable. The physics rewards correction, not volume. So if your grades aren't improving, don't study longer, study sharper. More reps won't save you if each rep repeats the same mistake. When more problems don't work, students try to push themselves harder. They wait for motivation. They try to force it. But physics doesn't run on motivation. Here's what actually happening. Motivation is unpredictable. It comes and goes. Physics progress doesn't. If your training depends on how you feel, your results will always be inconsistent. Most students believe when I feel ready, I will study. But physics doesn't reward readiness, it rewards repetition. Skills don't grow on good days only, they grow from showing up on ordinary ones. This is why long gaps appear. You skip a day, then another, then a week, and nothing feels broken yet, but momentum is already gone. Discipline solves this. Discipline is not intensity, it's reliability. It means studying even when the session feels boring, even when progress feels small, even when motivation is missing. Strong students don't ask, do I feel like studying? They ask, what is today's rep? They make training automatic, so effort is low and consistency is high. Motivation feels powerful, but it's fragile. Discipline feels dull, but it compounds. Physics rewards the second one. Now, if your progress feels random, stop chasing for motivation. Build a simple routine and keep it small. Repeat it daily. That's how skill accumulates. You don't need to feel inspired. You need to show up. Here's how you train this. Set up 10 minutes timer today. Study physics until the timer ends. Stop immediately when it rings. No extra time. Then go for the mid level. Pick a fixed time. You can study physics 3 days this week. Same time, same place. Even if you don't feel like it, show up anyway. Then challenge yourself. For one full week, follow this rule. You're not allowed to study physics for more than 20 minutes at a time. Short sessions only, no cramming. That's how consistency beats motivation. Here's where effort really gets wasted. Things start to feel familiar, recognizable, comfortable, and that comfort lies. Here's what's actually happening. You're confusing recognition with understanding. You recognize formulas, you recognize diagrams, you recognize work examples. Recognition feels like understanding, but it isn't. Recognition answers this question: have I seen this before? Understanding answers a different one: can I decide what to do next? Most students never test that second question. That is why studying feels good. You reread notes, you watch videos, you follow solutions. Everything looks familiar, but familiarity doesn't require thinking, it requires exposure. On exams, familiarity disappears. The problems phrased differently, the diagrams look new, the numbers don't match your notes. Now recognition fails and nothing replaces it because the decision making was never trained. That is why students say, I understood this yesterday but freeze today. They didn't lose understanding, they never built it. Strong students test understanding differently. They close the notes, they look at a new problem, and they ask, what does this situation ask me to do? If they can't answer that, they don't move on. They diagnose the gap immediately. Understanding isn't feeling comfortable, it's being able to act without guidance. If you can't start without help, you don't understand yet. That's not failure, that is feedback. Stop trusting familiarity. Start testing decisions. That's how real understanding is built. So students respond with intensity, long sessions, late nights, last minute studying. That intensity is not stability. Here's what's actually happening. Last minute studying feels intense, but intensity is not training. Physics performance depends on timing. Decisions must be automatic. Recognition must be fast. You can build that in just one long session. Cramming loads information. It doesn't build access. You might remember formulas, you might remember examples, but under exam pressure, your brain can't retrieve them reliably. This is why last minute studying creates false confidence. Material feels fresh, everything seems familiar, but familiarity fades fast. And when it fades, nothing replaces it. Physics exams don't test freshness, they test stability. They ask, can you perform this when nothing feels obvious? Cramming never answers that question. Strong students prepare differently. They study in short sessions. They return to the same ideas repeatedly. They space their practice. This trains retrieval, not just recognition. Spacing feels slow, it feels inefficient, but it builds something cramming never does: reliable performance. And if you rely on last minute studying, you're betting everything on memory. And memory breaks under pressure skill doesn't. If exams feel unpredictable, don't study harder at the end. Start earlier. Keep it small. Repeat it often. Here's how you train this. Today, study physics for 10 minutes. Stop when the timer ends. Do not continue. Then go for the next level. Pick one topic you are studying this week. Return to it for 5 minutes on 3 different days. Same topic, short visits. Finally, challenge yourself. For your next exam, follow this rule. You are not allowed to study physics for more than 30 minutes in one session during the finals week. All preparation must happen earlier in short sessions. That's how memory turns into stability. Now, zoom out. All of this effort is being applied to the wrong model. Physics is being studied like a subject instead of trained like a skill. Here's what actually happening. Subjects are learned by exposure. Skills are built by repetition. Physics is not a list of facts to remember. It's a set of actions you must perform. Setting up situations, choosing models, making decisions under uncertainty, those are skills. Studying feels productive because it's quiet and controlled. Training feels uncomfortable because it demands action. Most students choose studying because it feels safer, but safety doesn't build performance. This is why confidence feels unstable. One day you feel good, the next day you don't. That's not inconsistency. That's what happens when confidence is based on familiarity. And familiarity disappears under pressure. But skills don't disappear. Skills show up even when the problem looks new, even when the numbers change, even when nothing is obvious. That is the difference. Strong students train physics. They repeat setups. They practice starting problems. They rehearse decisions. They don't ask, do I remember this? They ask, can I execute this? Talent doesn't separate students in physics. Training does. The ones who perform are the ones who treated physics like a skill from the beginning. If studying feels endless and results feel fragile, change the model. Stop collecting information. Start training actions. So here's how you train these. Take one physics problem, do only the first step. Stop as soon as you finish the setup. No equations beyond that point. Choose one type of problem you see often. Practice starting that problem 3 times in a row. Do not finish any of them. Just start. Just set them up. Then challenge yourself. Once per study session, do this rule. Solve one problem out loud from start to finish. Say every decision before you write it. If you can't say it, you don't understand it yet. That's how studying turns into training. Here's the realization that changes everything. You don't need more effort. You need better reps. Effort without correction fails. Effort without structure burns out. Effort without skill training collapses under pressure. Once effort is aimed correctly, results stop being fragile. Let's log this in. 1. More problems don't help without correction. 2. Motivation is unreliable. 3. Familiarity tricks you into thinking you understand. 4. Last minute intensity doesn't build stability. And 5. Physics must be trained, not studied. This is why hardworking students still struggle. You don't need to sacrifice more time. You don't need to work yourself into exhaustion. You need to train the right way. Train the basics, build your foundation, and let consistency become your advantage. And if you need more help, the dojo is ready when you are. I'll see you inside.